So in the previous classes, we have discussed the importance of CAD-CAM, the role of computer in product design, then how that computer plays that role in the CAD and CAM part. Then we have discussed also what are the requirements, hardware requirements, software requirements for the CAD-CAM. So now, after the basic part of the computer and this input device, output device, we will go through the modeling part. Geometry modeling. What is geometry modeling? What are different types of geometry modeling for CAD? Okay, so geometry modeling is an important to CAD as governing equilibrium equations to classical engineering fields like mechanics and thermal fluids. So as we have studied that in the force equilibrium diagram, then thermal fluids, the governing equations are playing the important role. In the same way, geometric modeling plays an important role for the CAD. So, geometric modeling is an intelligent decision on the types of entities necessary for particular model. So, evaluation of the CAD-CAM system is very important. So, geometric modeling involves the innovative use of the tools in particular applications, creation of new attributes, or modifying the obtained understanding. So, the role of geometric modeling in CAD system is what? User interface, mathematical representation, computer display, drawing, generation, analysis. So what is a model? So model is a representation of a planned or existing object. Okay. So what are general requirements of this geometric modeling? Geometry, topology, then transfer data capability, supporting different softwares like FEM, FEA. So in the field of science, engineering, and agriculture, a model is constructed so that the object's essential information stands out in the model, and we can analyze the important aspects of the object while observing the model. Okay, so that is the importance of model. So in order to be concise and analytic, a model may be different from the object which the model represents in its scale, complexity, and appearance. So for instance, a model of a building may be built on a scale of 1 to 2000 so that the model can be placed on a desk and examining should be done on the architect from any angle. So that is the importance of model. So a mathematical model of a complex nature phenomenon may be built by choosing only parameters which play an important role in the phenomenon of interest. So in recent years, a mathematical model formed on the computer is visualized as a graphical image which we can understand very clearly. This process is called visualization. So model is the constructing model is a way of visualization, better visualization. Visualization, insignificant attributes of the object may be discarded. Shapes and colors may be given to the components of the object which are invisible to us in nature. Okay. An object is simplified and given a new appearance to become a model which is visible to us. So in the field of art, design, advertisement, communication, and other, a model on the computer can be a representation of a physical object which is being designed or analyzed on an object itself. So when a computer model represents nothing but itself, the words model and object are used interchangeably. Geometry modeling is a subject in 3D computer graphics which studies shapes of objects. Other characteristics of an object such as color, texture, density, material, temperature, and pressure are not in the scope of geometric modeling. A representation method is a set of rules used to describe the shape of a geometric model. For example, Maya uses a particular representation method for 3D geometries that allows users to create, shape, load, and modify 3D geometries. So using a representation method, a physical object can be measured and its shape can be represented as a geometric model on the computer. So a physical object can be measured and its shape can be represented as a geometric model on the computer. The shape of the non-existing object can be created directly on the computer and represented as a geometric model. So three major types of representation methods are surface models, solid models, and volume models. So why do we need multiple types of representation methods? It is because each type has advantages and disadvantages. You need to select the most appropriate model type depending on your purposes and applications. Each model that is representation method requires different modeling, manipulation, and techniques. So geometric modeling is only a means of not the goal. It is a method. Now it is not only the goal, but it is a means or method in engineering. Engineering analysis needs product geometry. So the degree of detail depends on the analysis procedures that utilize the geometry. There is no model that is sufficient to study all the behavioral aspects of an engineering component or a system. So geometric modeling attributes facilitate analysis and grow with applications. So basic geometric modeling techniques, as we know, surface modeling, so solid modeling, wireframe modeling, volume modeling. So wireframe surface modeling, what it requires analytical surface, curve and sculptured surface. In solid modeling, there are three different techniques like constructive solid geometry, boundary representation. So what is wireframe modeling? Wireframe modeling is developed in 1960s and defined as stick figure or an edge representation. But wireframe is related to the fact that one may imagine a wire that is bent to follow the object images to generate a model. So model consists entirely of points, lines, arcs, conics, and so. So in 3D wireframe model, an object is now recorded as a solid. In a sheet, the vertices that define the boundary of the object or the intersection of the edges of the object boundary are recorded as a collection of points and their connectivity. Then surface model. Surface model is a set of faces. A surface model consists of wireframe entities that form the basis to create surface entities. In general, a wireframe model can be extracted from a surface model. So surface model consists of different surfaces. So we can extract the wireframe model from the surface model also by deleting or blanking all surface entities. Then solid model is based on the half space concept. So the boundary of the model separates the interior and exterior of the modeled object. So the object is defined by volume of space contained within the defined boundary of the object. Generally speaking, a closed boundary needed to define a solid object. Informationally complete, valid, and unambiguous representation. So points in a space to be classified. So why we require solid modeling? Solid modeling is assumed as better technique. Why? Because in the solid modeling support is based on the volume information. So weight volume calculation, centroid calculation, moment of inertia calculation. So all things can be done in solid modeling. Stress analysis, FEM analysis, heat conduction calculation, dynamic analysis, system dynamic analysis. All things can be done for the solid model. So that's why solid model is used on the greater extent. So using volume and boundary information, generation of CNC code is important, is very useful and very easy. And routing and assembly simulation is easy. So that's why we use for soil modeling. Soil modeling is based on the three techniques like sweeping, constructive solid geometry, boundary representation, feature-based modeling. Okay, then primitive instancing cell decomposition. So in this primitive constructive solid geometry is based on the primitive instancing, which uses a large number of primitives to build object, used for programming NC machine tools like this. Then cell decomposition. So among these surface modeling is generally used for computer animation. Soil modeling used for engineering, manufacture, computer-aided design. Volume model, scientific visual, medical visuality, volume models are there. So when an architect pre-visualizes the exterior of a building under consideration for a customer, surface models may be appropriate to use. So when an architect wants to predict the stress on a structure constructed with a new material, soil models may be used. So soil model is soil modeling is suitable for all the analysis like stress analysis, structure analysis, load analysis, this volume calculation, stress calculation, okay, deformation. So all things can be done as soil modeling. So that's why soil modeling is used. Surface model is not appropriate to use only. So when an architect wants to predict the stress on the structure, so that in the soil modeling may be used. So when an architect simulates the effect of dust of varying density on lighting in a room, volume model is probably the most appropriate. So volume model represents the contents and cell of an egg. A soil model represents the complete egg cell and the space included by the cell. Okay, so this is the difference. A volume model represents the contents and cell of an egg, and soil model represents the complete egg cell and the space included by the cell. Surface model is represents the fraction of the egg cell or the complete cell. So surface versus solid. Surface models can represent the surface that encloses a finite amount of space and a surface that does not enclose a finite amount of space. So the former is called a plot surface and later is an open surface. Surface models can represent surface that in finite amount of space. Soil models always represent surface that includes finite volumes that exclude a space. So solid versus volume, what is the difference? Solid models always have crisp surfaces, while volume models can have fuzzy surfaces and can represent fuzzy stuff like a smoke and clouds. So the interior of a solid model is always considered homogeneous. While the interior of a volume model can be inhomogeneous also. So that is difference between solid modeling and volume modeling. Solid modeling have crisp surfaces, volume model have fuzzy surfaces. And the interior of solid model is always homogeneous, while the interior of solid model is always not homogeneous. It can be homogeneous also. So whatever we have studied in summary, the geometric model contains description of the model object shape. Since geometric shapes are described by surfaces, curves are used to construct them as they are easy to manipulate. So in the summary, we can say that a geometric model is shows a complete description of any model object. So geometric shapes are made with the help of surfaces curves, so that they can be easily manipulated. So the curves may be constructed using analytic functions, a set of points or other surfaces and curves. So surface modeling teaches how to build free-form shapes. Soil modeling digital representation of the geometry, which is under the feature object. So whatever we discussed among the wireframe modeling, surface modeling, and soil modeling is used generally suitable for the modeling because it is a sort of digital representation. It is shows the how a object look like from the interior as well as exterior point of view. So we can do all the calculation, stresses analysis, structure analysis, information analysis. All the analysis can be done on the soil modeling. That's why soil modeling is used on the larger scale and in the common life. Okay, but in wireframe modeling, we show only the corners, edges, and can be seen only. So we cannot analyze the load analysis, so the whole the part and so on. So soil modeling is generally on the larger scale. Okay, have a nice day. Thank you. So, then whatever we have discussed in the last class and this class that importance of CAD-CAM, then how this CAD-CAM is important in different areas, then what are the different requirements for the CAD-CAM, hardware requirements, software requirements. Okay, then we discuss the how the CAD plays an important role in how we could define the model, what are different techniques of solid modeling, how wireframe modeling is uh, less beneficial than the soil modeling. Soil modeling, the importance of soil modeling, where it is used, and what are the different techniques for soil modeling also. How soil model is better than other models. How the surface modeling is less beneficial than the soil modeling. Okay, so this in we have discussed. So after that, we will discuss the transformation is how can we transform the model from one point to another. How can we scale the model? So transformation we will discuss in next class. Okay, thank you for your patient listening. Thank you.